Welcome back to another episode where we continue to look at the Thor in Reason 9.1. This time, let's take a look at the mixer and start to look at the filter section. So, to look at the mixer, let's turn on some oscillators with some different sounds. Don't need to do that yet. Turn that off. Trying to get some unique sounds going on. Okay, so now you can hear a low rumble of a sawtooth and then a high-pitched sine wave. Let's turn on another oscillator. Let's do let's see what would be a unique one, like a noise maybe. And then we can hear the noise there. All right, so the way this mixer works is kind of weird because it's not just three sliders. It's a balance between, let's turn off slider 3. It's a balance between 1 and 2. And that's controlled by this, also controlled by this slider. But this is a slider for 1 and 2 simultaneously. So if we turn that up, then that's 2. And then we turn, that's 1. Now if we just want 3, then we turn this one down, and then we turn 3 up. So I believe the reason they did this is so you can program this button, or program this control, and you can LFO it between, here and here. So you can get crazy effects, as opposed to having to adjust 2 sliders simultaneously. But it does make the control kind of weird. Then you have these buttons, and like I explained before, these turn on and off the routing to. So right now I hear nothing if I press a key, even though this volume is up. So this controls the routing. And if I turn this on, I still don't hear anything because this button's off. So this button controls whether this filter does anything, strangely enough. I don't know why they put this button in here, but that's what they did. So now we're sending both sending, let's say, oscillator 1 up to this filter, oscillator 2 and 3 to this filter. But these filters are bypassed. So let's take a look at how the filters work and turn off all this extra stuff. So now we just have a standard sine wave. Let's turn it down a little bit, make it a little bit less noisy. Sounds good. Let's go to a sawtooth so we can actually hear some frequency in there. So just like the oscillators, there's a whole list of filters you can apply, 4 different filters, and those apply to each of these. The same 4 apply to each of these filter slots. And so let's look at each one at a time. So this is the low pass ladder filter. Let's read about that in the manual, since the manual actually says something kind of interesting about this one. So the ladder LP filter is a low pass filter inspired by the famous voltage controlled filter patented by Dr. Robert Moog in 1965. The name originates from the ladder-like shape of the original transistor capacitor circuit diagram. The original filter had certain nonlinear characteristics which contributed to the warm musical sound it is renowned for. These characteristics are faithfully reproduced in the ladder LP filter. All right, so let's listen to that. So if we turn the frequency all the way up, it lets everything through. And as we turn it down, you get just the low frequency through until you basically get nothing through. So pretty standard stuff. Then you have a drive knob, which controls how much you're driving the filter, kind of like an amplitude. So you can overdrive the filter to make it louder. Then you have a resonance knob. Okay. Then you have over here you have how much per decibel or per octave, how many decibels per octave you're driving the frequency. So you have two 24s, and we'll look at the difference between those two in a second. An 18, a 12, and a 6. Let's listen to that, how that works. So you can hear that a 6 is a weaker push than 24. Okay. Then you have this stuff down here. We'll deal with the invert button in a second. That's an envelope invert button. Both of these guys, both of this velocity and this invert, drive and alter this guy, which is an filter envelope amount, how much to apply the filter envelope, which is down here. So this is an ADSR filter. So if you haven't already, the manual actually describes, if you haven't seen it, describes the envelopes in a pretty nice way. So it gives you this diagram. So the way these sliders work is you have attack, delay, this is delay, sustain, and release. And so what attack does, it's the amount of time in order to build up to a certain amount, to the maximum value, and then you decay down to the decay is a time to decay, and then sustain is a level set to how much you want to sustain at, and then release is a time to release. So let's listen to how that works in a filter sense. So if we turn up the filter to actually apply it, so right now, since I have everything kind of off, there's no attack, no delay, and no release, so everything's instant. And our sustain is at negative infinity. If I turn the sustain to 0, as I apply the filter envelope, you can hear this filter is not doing anything. It's not cutting out any frequency. Like only at the very low end is it actually cutting out the frequency. But it's nowhere near like this. We should hear it like this, where it cuts out most of the low pass. But the sustain basically sets how the strength of the filter. So you can see there, it's like negative 17 decibels. So it's kind of like this, but this is per octave. So it's a different kind of, as you play higher and higher notes away from higher and higher frequencies, this is a per octave strength, and this is more of a global filter strength. So let's listen to how the attack works. So you can see it's like letting in all the frequencies up until 1 second. Up until 2 seconds, 3 seconds. Then there's a decay, so let's put the attack at like 1 second. And then it's going to decay down to the sustain. See, if I turn the decay off, it's a hard cut. So you hear that hard cut right there after 1 second. If I put a delay in, it's a softer edge. It's this softer edge sweeping down to where the filter takes effect. And if you put a release, then let's turn off this stuff. See, I don't think we can hear the release in this way. All right, so let's look at this note velocity stuff. So if we drag our virtual keyboard back and we set the velocity to 127, we hear the filter in full effect. Let's see. What's it doing? Okay, so because I had the sustain all the way down, it was this velocity wasn't taking effect no matter what velocity I set it at. What you can do is you can set the sustain higher to, like, let's say -10, and then fast notes, like hard hitting notes of velocity 127, are so strong they don't hit the filter, so you can hear all the frequencies going through when this velocity knobs all the way up. Now weak notes do hit the filter. And if you turn that all the way down, then everything hits the filter just as you'd expect. Yeah, so that's velocity. Keyboard is how much if the pitch actually affects the filter. Let's see if I can demonstrate that. So much the keyboard impacts the filter. I think it's kind of hard to showcase. All right, then the next thing we should look at is this self-oscillation stuff. This self-oscillation goes in hand with the shaper. So if we have to talk about the shaper too. All right, so let's look at the shaper docs. Don't think they're that long. So wave shaping is a synthesis method for transforming sounds by altering the waveform shape, thereby introducing various types of distortion. A shaper can radically transform the sound or just add a little warmth depending on the mode and other settings. So there was a drive button. So basically you have to turn on the self-oscillate and the shaper, and then you get to choose one of these modes and then the amount of drive you have for it. So let's listen to a soft clip. So here it is without the shaper. So the other thing to note is that these things, there's type 1 and type 2. So type 1, if we go back over here, the shaper is placed at the filter output, but before the feedback loop. And type 2, it is placed in the filter input after the feedback loop. So if you want the filter to be applied after the feedback loop, do type 2. So some of these, it's kind of subtle, but it is there. So that's the idea of the shaper. You can kind of create a little bit more interesting effects with it. Yeah, then the other thing to kind of note before we start getting into the next section, which we'll do in the next video, is you can route the output of filter 1, this guy, through the shaper optionally, and then you can optionally route him directly to the amp or route him to filter 2. So you can actually say, okay, well, I want 2 filters. You could do we haven't looked at these yet, but you can route, say you want 2 low-pass filters. Or one of these other filters in there. So you can double filter it. All right, let's continue on our journey to look at the other filters. So the shaper's off. So then we have a state variable filter, which is similar to what we saw before. It has these same buttons, so I won't bother describing that, and a drive, so that's kind of the same, and a frequency and a resonance knob. But the main difference is you have a low pass 12 decibels per octave, just like we saw before. It does the same kind of low pass frequency cutoff. But then you also have band pass, which lets a specific band through. High pass, which lets only high pitched sounds through. So that's letting only high pitched sounds through. And then you have a notch and a peak. So those are two different wave shapes that allow you to set where that notch or peak sits. So you can either set it at the low end frequencies or the high end frequencies, or you can do a peak. They sound pretty similar, but peak is kind of tighter, I suppose. And then you have resonance, of course. So if you're... So, kind of a simple filter. So comb, let's read the docs for comb. So a comb can add subtle pitch variations and phasing-like effects to sounds. Comb filters are basically very short delays with adjustable feedback, controlled by the resonance knob. Comb filter causes resonating peaks at certain frequencies. It can be used in various signal processing devices like flangers and produce characteristic swooshing sounds when the frequency is swept. Comb plus and minus alters the position of the peaks in the spectrum. Okay, let's listen to that. So that's kind of the basic idea. So you can you can hook up an LFO to these things and make it sound more wacky. The formant is another weird filter which can produce vowel sounds. So if you remember in the presets, so there was a bunch of voices. A lot of these are with formant filters, and then you have X and Y, which basically control kind of how it sounds. And then there's a gender parameter which alters between male and female vocal characteristics. Let's listen to that. And of course, it's all like dependent on your oscillator and the frequency that you're sending through here. So if you send something that sounds kind of human, sounds kind of human, you'll get a better effect. And that's it. So there's only 4 of them, so it's not too bad. All right, so we took a look at all the filters and the mixer and the shaper and kind of this routing table, these routing arrows. Next time we'll take a look at the amplifier and start to look at these LFOs and continue on the line. All right, see you next time.